How to measure recursive algorithm. Now in the last lecture we have learned how can we measure any given code using 5 rules. Now here we will look at how can we measure recursive algorithms. So here again I'm going to use the previous example that we used to measure the iterative calls. So here we are given a sample array, so we need to find a biggest number. But in this case we are going to write the function to find the biggest number with recursive call. So this is our function. So this function takes as a parameter sample array and n here is the size of array. Then when the size of array reaches to 1, we are returning the first element from the array. Otherwise, we are comparing the current element, which is the last element in the array, with the return value that comes from the function with the parameter of n-1. Now, before continue to find out the time complexity for this method over here, let's see how this is working. So I'm going to take as an example simple array over here. So in this array we have 4 elements and n equals 4. We will look at how this function works for this array over here. Now if we run our function for the array of a with the parameter of 4, then it's going to call itself recursively with the parameter of 3. So it will take as a parameter same array and the second parameter is going to be 3. Then this function also will call itself recursively. So in this case the parameter will be 2. So the first parameter is the array that comes from here and the second parameter is 2 because here we are calling it n-1. It continues until we reach when n equals 1. Now when n equals to 1 we are returning first element from this array. So in this case the first element is 11. A with the index of 0 is 11. Now from this function with the parameter of 1 we are returning 11. So this means that we can go to this function over here. Now in this case we have to compare it with the value n-1 with the 11. So in this case you see that n is 2. So n-1 will be a with the index of 1 which is 4 and the return value that comes from this function is 11. So if we compare it you see that we have 11 over here. Then it continues to go to the next function. In the next function we have n parameter 2. So this means that it's going to compare the value that returns from this function with the parameter of 2 which is 11 with the element that's located over here with the index of 2 because n is 3 so the index of n-1 will be 2. So if we compare it from here we get 12 and we got 11 from previous function. So if we compare it we are getting 12 over here. Now in the last step it's going to compare the value that comes out from this function with the n-1. So n-1 will be index of 3. So in this case we have 7 over here. So if we compare 7 with 12 we are getting 12. So the maximum value from this array is 12. So this is how this function works in the background for finding the maximum value from this array over here. Now this is how recursive function works for finding the maximum value in the array. Now let's see how can we find the time complexity for this algorithm. Now when we define the time complexity for recursive function, we have a standard. So here the first thing that we are going to do, we are assuming that this function takes mn time complexity. So here we are just assuming that this function takes mn time complexity. Then we are continuing to the next line of code. In the next line of code we have if condition. So this means that it's going to be O1 time complexity because according to our 5 rules, the if condition takes O1 time complexity. Now then we are continuing to the next line of code. So in the next line of code we are returning a value from array. So this one also will take O1 time complexity. Basically accessing an element of any array takes O1 time complexity. We will talk about this in the section of array. Here you just need to know that accessing any given element in the array takes O1 time complexity. So in this term array is very fast. Now then we are continuing to the last line of code. So in the last line of code you see that we are accessing an element and then we are calling this function recursively with the parameter of n-1. So here we assumed that it takes mn time complexity. So if we call it with the n-1 parameter, it means that it will take mn-1 time complexity. Now based on these time complexities over here, we can write that mn is equal to O1 plus O1 plus mn-1. So if we have 2 O1 over here, we can remove the constant from here and we can write it 1 O1 and the second mn-1 can be written like this. Now this is our equation for this recursive function. So we can write our equation like this. So if we put instead of n over here 1, So it's going to be mn is equal to O1. Because here it's going to be 0, so this is eliminated. So it's going to be mn equals to O1. n minus 1, the equation will be like this. mn minus 1 equals to O1 plus mn minus 1 minus 1. Now if I put mn minus 2 instead of n over here, so the equation will be like this. Now by combining these equations, we can write that mn is equal to 1 plus mn minus 1. Now from here we know that mn minus 1 equals to this expression over here, so we can take this expression, put to the place of mn minus 1 over here. So if you put it, it's going to be like this, plus 1 plus mn minus 1 minus 1. Now if we calculate this, it's going to be like this, 2 plus mn minus 2. Now here we have calculated mn minus 2, so if you put the expression over here, it's going to be 2 plus 1 plus, well, it's coming from here, and mn minus 2 minus 1. So then if we calculate this, it's going to be 3 plus mn minus 3. Now if we continue like this, we can conclude that we can write this expression like this. So a plus mn minus a, because you see that in the first stage it was like this, 1 plus n minus 1, and then if there is 2 over here, we have 2 over here. If there is 3 over here, and we have 3 over here, so we can conclude that we can put a over here, and it's going to be minus a over here. So here we have to eliminate m function from here. So how can we eliminate m function over here? We know that m1 is equal to O1. So if we can make this equation over here to m1, it means that we can eliminate it. So to make this equation to m1, we just need to replace a with n minus 1. So if we replace it with n minus 1, it's going to be like this. So m minus 1 plus mn minus n minus 1. So if we calculate it, it's going to be like this. N minus 1 is equal to n minus 1 plus 1. So at the end, it's going to be n. So this means that we can write this as On time complexity. So hopefully you have understood how can we find the time complexity of recursive algorithms. But here there might be a situation where the function calls itself twice in each step. So in this case, how can we find the time complexity for it? So let's look at this in the next lecture. So see you in the next lecture.